Hi, and welcome to this week's Background Fundamentals. Well, Christian from Vienna, in our forums, in the background section, when I asked for ideas for this term, asked if we could look at live, real-time green screen compositing. And we thought about this a lot as to how to do this, because obviously there are a lot of aspects of it. And generally speaking, just straight keying in live sort of situations isn't that hard. We've been doing it for a long time with news and weather presenters in particular. What's really interesting if you can do it in a narrative form and you can deal with the entire problem. And to do that, we've gone to Los Angeles to speak to Lightcraft Technologies, who have in fact solved the whole problem. And the place that they're doing this at the moment that's most interesting is in episodic television. So programs like Once Upon a Time, programs such as this are actually filming and seeing in a viewfinder right next to the eyepiece on a handheld camera the final composited picture as they walk around actors on a green screen stage. In other words, the system has been built to such a level that not only are they doing keying in real time, but they can work out where the camera is. They can then, of course, do the key, get all the lighting right, and generate the background that's normally completely electronically generated, composite the two together and feed it back to a monitor on the camera so that the DP can line up. Because if you think about it, if you do this process live, but there's a latency of a second or two, if I was panning onto a virtual piece of prop, perhaps, let's say I wanted to pan onto a virtual car. Well, as I got to the hood and decided, yes, that's the shot I want, that's the framing I want, if there was a second lag, of course, I'd see that a second after it was there. So when I stopped, I'd actually be stopping on an overshot point. And then I'd, of course, move back to get where I wanted to be. And so you'd get this horrendous latency problem of not being able to line up on something. Now, for it to work, you have to have the whole system, background generation, keying, camera tracking, the lighting, everything has to be solved in real time with very, very low latency. Well, the company that's doing that work in episodic television, Lightcraft Technologies, has generously allowed us to go in and actually set up some stuff and do it for real. So John and I went over to their offices in Venice and actually went through the team, how they do this in a real-world environment. I apologise for the goofy performances by yours truly, but it was really, really interesting to see this in action. And thanks to Christian for suggesting it. Well, thanks so much for joining us. We really appreciate it. So we're standing on a green stage. This is obviously a pretty small stage, but your company is at the forefront of basically solving the entire problem of us on this green to actually complete its stuff in what seems like an astonishingly short time frame.
Yeah, real-time visual effects. All the different pieces that are in a visual effects pipeline, but done in real time.
So most of us, I think, would know your work from episodic television. Certainly, we've done a lot of stories on FX Guide about the adoption of virtual sets. I mean, was that always the brief for the company when it started?
In many ways, what we started out as is, the company started out in a lot of ways of me trying to do some initial visual effects shots and teaching myself some of this, and being blindsided by how hard it was. Like, I just couldn't believe how I sat down and learned some tracking and learned some keying, etc. And it wasn't just one thing. It was everything I tried was just beyond difficult. And partway through, I went, who does this stuff, right? But during the course of being dragged through the bricks on those couple of shots, I saw what the math was. I could see the underlying mathematics of how it worked. And I realized from a background of robotics is that we could do this a different way. The parts that were excruciating, like the keying and then the compositing and the extracting where the camera was and what the lens is doing, the distortion, all these things that were very, very painful. I thought, wait a second, we can just measure what the lens is doing and then we wouldn't have to try to figure it out afterwards.
Well, on a show like Once Upon a Time or something like that, we've got the phenomenon that you're going to need a lot of flexibility on set because each week, different story, different sets, different requirements. But not only that, we have this sort of overriding machine that is the production for episodic television, where they're not working on a shot or a show. They're working on like 8 at once and they're staggered. So pipeline becomes everything.
Yeah, the rate of speed, those shows are going upwards of 250 shots per episode, and the turnaround is on the order of a couple of weeks. And at that point, you simply have to have data automation to handle the tracking, because otherwise you'll simply bottleneck on tracking that alone. And you just can't brute force track that many shots in 2 weeks without arbitrary numbers of people. So in that case, what the system does is records data for use in post-production and solves a lot of the tracking.
Now, what your Emmy Award-winning sort of entire package is used for is only partly for that pipeline of an episodic where we're thinking about 8 shows in production. There are actually other shows that are completing the comp basically in real time.
Exactly. Probably a third of the work is in recording data and then using that for post-production, and then nearly 2/3. And this is one of the things that really surprised us during the course of starting the company and moving along, is that at a certain point our keying and rendering got good enough that people said, we want to use this as a final comp. And that threw us into a whole nother range of things that so now probably 2/3 of the work that we're involved with is actually finishing in-camera visual effects.
Okay, so what I thought we'd do, if we could, is just walk through the pipe in stages. And so from my sort of outsider point of view, there are some obvious problems that you need to solve. I'm sure there's more than this, but let's work our way through it. So the first thing is basically you need to know where the camera is relative to us. Now, we're standing here or sitting here on a green screen stage. I'm not seeing any tracking markers around us, which means the keying is going to be easy because we don't have to worry about me overlapping with dots. Kind of need to know how the camera knows where to put the background relative to us. So how do we solve camera position relative to us?
All right. So there's 2 major pieces. Where is the camera, and where is it pointing, and what is the lens doing? And I will actually weight the lens 50-50 with the camera tracking itself, because it makes such an enormous difference on where, on the final solve. So should we walk over by it?
Let's do it. Okay, so this is the camera that we were just being filmed on. So what have you got on here to know where it is?
Sure. All right. So there's a combination of sensors that we put on here in order to read all the different data components. So here we have a little InterSense optical tracking camera. And so this looks upwards, or actually we can orient it in different directions. It's got about a 90-degree field of view. And as soon as we can look up and see 4 of those circular barcodes overhead, they're called fiducial marks. And each one of them is unique. So as soon as we look up and we see 4 of those, we can lock our position in the room.
Right, so basically computer vision on knowing where I am.
Exactly.
Is that enough to just have that?
So that gives us a start, but the data from an optical solve ends up being pretty noisy. So we ended up needing to build a very high accuracy electronic gyro, and that's the air track.
Right.
And to fuse the data from the positional data here and the rotational data from the air track. And this is sort of a good example of the movie, TV work is very specific, and you need to build things that are very specific to that. In this case, what we needed is a very high accuracy gyro that's synchronized to video signals. And so the video signals will come out at 23.976 or 29.97 or et cetera. To get tracking to really work right, you have to be both accurate where you are and what you're doing, and you have to be accurate in time. Like you have to frame trigger the gyros at the exact moment that the camera is capturing that image on the sensor. Otherwise, you have these like strange artifacts.
So to be clear about this, all that tells me where the camera is and where it's leaning is those. It's not like you've got a geared head with a motion sensor or anything. Everything else is pretty much standard gear, I guess.
Exactly. This lets us handle freeform tracking.
So I could go shoulder mount and it would
Yeah, I mean we can do that if that would help.
We'll do it in a sec, yeah.
All right. So we fuse. So this brings us position. This is orientation, and then the last component is the lens data. So I have a lens follow focus controller here. This is an Element Technic controller, but we work with basically all the different ones: the Fujinon, Canon, Preston, C-Motion, etc.
Yeah.
Whatever people happen to be using. So as I zoom in and out, the virtual background zooms in and out as well. And what's going on here is a set of many different things. One, we're synchronizing the data transfer from these in synchronization with the video signal. Everything comes from the video signal in terms of how we render, how we look for data. Say, okay, we've got a new frame of data. Let's go find the rest of the world and synchronize it. So the next thing is that we had to build a very accurate map of what the lens optics are doing. And this is one of our patents because we had to develop a system that can calibrate an adjustable cinema zoom lens throughout a very wide range of zoom and focus.
Right, the key word there being zoom, right? Because
Yes.
if I just had a 50mm prime on here, it's almost a given where the kind of nodal focus point of the actual lens optics is. But if you're talking about arbitrary zoom lenses, that can literally move as the zoom changes from extreme ends.
That was a really fundamentally tricky area because...
Is that something that you can get from the lens? No?
This,
How do you do that?
Turns out to be data that you really can't get for the most part. We needed to find a way to measure where that entry pupil, where the nodal point of that lens was.
Yeah.
And the way you traditionally would do it is you send it off to an optical bench in France, and they take it apart and they send you back in 3 weeks your lens with some data. That turns out to not work so well for episodic, where you need to calibrate the night before. So what we built is a lens calibration tool, and that has a moving fiducial grid that we put in front of the camera. It's motorized, and for each combination of a zoom and focus, we'll capture about 20 images of that going in different directions. From those 20 images, we can do a full optical solve that actually gives us the true optical parameters of the lens, not what's printed on the barrel, because they standardize that, and it's sometimes close and sometimes not. But what the actual distortion is, what the actual focal length at that point.
I was going to say, because there's lens distortion, of course, but what we're actually talking about is the nodal point shifting, which is a much harder thing to kind of, because you can't solve that in post just off a normal image.
Right. And it's that optical solve that lets us determine and calculate. So for example, in a camera like this, the nodal point will start out near the front of the lens. That's typical for like a broadcast zoom. And when you zoom all the way in, the nodal point is back here.
Wow.
It moves a lot, and it varies from one lens to the next.
Because the thing is, you could say, I guess you could try and say you can only use primes, but that's not going to fly with the production. But secondly, it is actually kind of advantageous to have a zoom on here, because it does mean that you don't have to break the rig down to change for the next shot. So presumably, if you've got the flexibility and the director and the production are happy to work with the zooms, once you've set it up, it presumably holds then for the shoot.
It's interesting to see, especially for the episode, when they have to go very, very fast, they park a zoom on it and they just go. And in fact, a number of the shots that we've watched people do are exactly the nightmare shots for tracking. So they'll creep along very slowly, and then someone's going to crawl in on the zoom. And that we can track that just fine. So this is a good example of what the math is doing. So this is a really good example of what's going on. This is our virtual camera. This is the virtual frustrum. This represents the entry point of the camera. Now, as I zoom in, you'll see the frustrum narrows, and that lens goes and that's where the sensor is. And this is one of the things that was very intuitive, not intuitive.
Yeah, it goes past the sensor.
Right. And the first time we solved that, I went, is something wrong? And then I made a few phone calls, and they're like, oh yeah, it does that. Wait, how'd you find out? And so in the course of having to solve this problem, we basically had to come up with a way of determining what no one wanted to talk about.
It's interesting because your approach is kind of different to my standard approach. My standard approach is I film the environment with tracking, and then I solve for where that point is. And I don't actually care what the physical camera is, because of course the solve is the solve that the PF track or 3D equalizer gives me. I would never even be aware that that was the case, because what do I care, right? I just care where the camera solve locks the vision to. The point is, you don't have the post-production solve down here.
Right.
You're basically not solving the camera position so much as actually knowing where the camera position is.
Yeah, we're measuring these components in real time. For the camera calibration, we'll go through the sweep of the zoom and the focus of the lens, doing a calibration, every incremental step until we have a complete mapping of that lens. And then when I zoom in real time, it just always knows what we're doing.
So if I was on set, would you have to run some calibration thing on the camera and the setup at lunchtime and in the morning, or is it just once it's set up, it'll run for the next few days? How does it work?
What we'll typically do is a tech day. We'll combine kind of surveying, which is locating the positions of all these trackers overhead using an architectural total station, and also lens calibration, which for a zoom lens will take about 3 hours to go through that mapping. Once we go through that initial mapping, it's saved in a file that's specific to that serial number and that model of lens. And then when you're shooting on that lens on future days, you file, load, and go. Then it's very, very quick. But by doing it on a tech day, we can actually essentially solve all the lens problems before you're in post.
Okay, so one of the things that we've got, if we've got the camera position, we've now gone handheld on this, is we are seeing the background being composited in real time, which means you have to generate a background in real time because we can't pre-render, because as the camera is moving, it has to be with us.
Exactly. This was one of the other areas where we started out, what I thought we were doing is more proxy geometry. What people kept wanting more and more, as soon as people see it in real time, they really want to see it. And so that's prompted a rapid development of the rendering technology so that we could actually do this, do it well. So there's a few different areas. One is that we had to build loaders that could handle visual effects level like textures. So instead of as opposed to more video game kinds of things, we end up dealing with things you'd have to load in from Maya with like a 32K texture. So if we, for example, we zoom in on the wall over there, I'll zoom in over here. So we can get to the point where we're rendering, and so I'll do a little bit of depth of field. So we actually need to render at very high levels of detail. If we're in a 3D environment, we're going to walk around. We need to hold a level of detail at all these different points in the 3D environment that holds up when we walk close.
You don't have to be loading a different file for the close-up than for the wide.
Right. And that just simply means very large texture sizes. In addition to being able to render in real time and have that synchronization, we need to have all the different lens effects that people are used to. So what I'm doing is I'm defocusing with the camera. And this was one of the areas that took a while to get right. So if I rack focus to myself, what's going on here is just another extension of the lens calibration, where since we're accurately measuring exactly what that lens does, we know what the sensor size is, we know what the f-stop is. What we're then doing is then generating an amount of blur in the background that corresponds with where that 3D object would actually be.
And that's incredibly important for selling the comp, right? That the background is blurred at the right amount for the lens and not sort of an artistically, maybe technically wrong kind of level.
Yeah, we actually do the full optical circle of confusion calculation, and that way you can actually, the goal in all this is whatever that camera is doing, that's what we want to tell the visual effects rendering side of it to do. We just want to try.
I've seen pipelines like this, and there's a latency that's much bigger, which means it's kind of hard for the camera operator because they're looking and effectively they move, and then the comped picture takes like half a second to get there. So they've actually panned past what they want to do, and then they're going to come back again. So getting that latency down and thus very fast rendering has got to be pivotal.
That was, in many ways, the course of all this has been a fight for milliseconds. So to do a given frame in 24 frames a second, et cetera, you've got about 42 milliseconds to make it through. If you're at 30 frames a second, you've got 29 or however many ends up being 33. So here's the course of how it happens. We have a few milliseconds to pull in the data from the sensors. We've got maybe 6 to 10 milliseconds to render the whole screen. We have a few milliseconds to pull a key. We have to then defocus all that, put the comp in, color correct it, and make it back out to the HDSDI outputs so the camera operator can see this with a delay of about 4 frames.
So you must be using GPUs like no tomorrow.
We, in many ways, when we first started was at the company in 2004 was exactly the point when the GPUs started to come on, the programmable GPUs started to happen. I tried writing our first keyer in standard definition on a CPU, and I think we got about 4 frames a second, at which point I realized
this that's just the keyer, right?
Yeah. Nothing else going on. Then, right at that point is when the programmable GPUs started to hit. They were hideous to program, but you could make it work. And so that's where we've been. The interesting thing is that we have to use both the GPUs and the CPUs, but in very, very different ways. We'll use the GPUs for the rendering, the compositing, these sorts of things. But we actually run out of GPU. When we start to do things, for example, in the telenovela type work, where we have to decode multiple 4K plates in real time, then we actually need to use a very highly parallelized...
So let me just back that up for a second. You're doing 4K on that?
So we'll do multiple 4K backgrounds for the telenovelas.
Okay.
They're pushing us very hard technically. So there's a whole interesting talk about telenovelas and interlace.
I just assumed that they'd be 1920 by 1080.
So the rendering, the real-time camera is 1920 by 1080. The background, since you have to be able to zoom into it and pan around, you end up shooting multiple 4K plates that you have to decode that all live. So then you have a room to kind of move around inside it and still hold up in resolution.
Right.
So what we have over there is a system that has the best GPUs you can get, the best CPUs you can get, and is liquid cooled.
How many GPUs are in the box?
That one has one. It's a K6000.
Okay.
And
everything just gets better, right? I mean, GPUs get better. You know, wherever we are now is not the end story. It's just a story in progress.
What we've effectively done is we've spent most of our effort on the computer side on optimizing code. So we made it work with circa 2005 GPUs, and then as the GPUs come out and get better and better, we're able to add more and more like algorithmic improvements, another layer of keying, another level of color correcting, depth of field. So as the GPUs get more powerful, we can simply add more.
Right. So our background is being rendered in real time, and it's presumably, it seems to be anyway, fast enough in terms of low latency that you can pan onto because the camera operator should point this out, is seeing that comp feed, right? So they can find that ledge that you were just referring to. They can find that virtual prop and point of story interest that we're meant to be focusing on. And they can do it in enough time to be responsive. But you still have to key us and put us over that background. So let's head over and have a look at the box and see how it works. Okay, so this is the station. In fact, what am I sitting in front of here? Because there's a couple of, this looks like the main unit, is that right?
Exactly. So this is the Prevision portable.
Right.
This is the main processing system. And we have these both in a portable and rack mount units, just depending on your needs for your stage or if you're in an installed area. The portable development came out after lugging around a studio version in a big road mount case and having it dropped off a loading dock, at which point...
The realities of production. Now we've got a skeleton in shot here, and that's coming off the laptop, is that right?
Exactly. So what's going on with the skeleton in shot is that we've got some recorded motion capture animation data playing back from Motion Builder, and we have a live network link between Motion Builder and Prevision. We also have one between Maya and Prevision.
But who's rendering the skeleton?
So the skeleton's being rendered inside Prevision. And what we're just doing is taking the transforms, the skeleton hierarchy, transmit it over the network into Prevision. And
is it in camera space here, or is it just getting it in camera space there? It looks like it's getting it in camera space here, right?
So they're both matched coordinate systems. Okay. And so wherever in XYZ, it's in Motion Builder, it'll show up in XYZ. It's a one-to-one transfer.
Okay.
And that way we can bring in complicated animation from those systems without having to try to figure out how to translate rigs. We just take the actual data. And that lets us handle some really interesting areas. I have some videos of us recreating one of the Harryhausen sword fights with a person in a green suit with motion capture driving a skeleton in a sword fight with a live action guy.
Right, so you can actually do a motion capture feed loop around that's fast enough to be able to do on-set interaction.
It's synchronized in real time. The data is correct.
Right. And in fact, I think there was a SIGGRAPH video that you did that showed that, with somebody moving in sync, or I guess beside their own capture.
Yeah, we had a dancer in a Movin suit, an Xsense suit, and that was piped into Motion Builder, real-time data. We then transmitted the character solve over into Prevision and rendered a robot, so she could move her arm in and out and drive the robot in real time with full compositing.
Okay, so let's get back to the keying, because that's one of the things that I know and love. How are you doing your real-time keying? You said it was GPU, but what control do you have?
All right, so keying was one of these areas that I just didn't it staggered me how difficult it was going into this. I'm like, what the? And so I looked around at many different areas and wrote the initial couple keying algorithms, which gave me terrifying results. And then I ran into one of the ones that I liked, which was a DVMAT algorithm, and that I thought, no, this actually works pretty well. So we licensed that, and then we implemented that in the GPU.
It was written by Ben, right?
Yeah, smart guy. Then we also added a few components where what I would run into is specific cases based on what we were running into the stage. So I'll go through some of the setups. So I'm going to reset, and this is all. What this is, in many ways, is really set around having to go very fast on a stage. Like this is, so we'll start out. This is just the default. We'll just reset to green. So then we can take a look at what does our mat look like. Okay, that's with some default high and low colors, but we'll go and pick them. So we'll go and start off with picking a high color. This is another little diagnostic tool. So in real time, what we're doing is we're sampling the underlying green screen, so we can see what our high and low colors are.
Yeah.
And this was an education, because as soon as you do this, you can see what paints are really good out there and what's just going to cause you problems. Like a old chroma key green has very low separation between the red channel and the green channel, whereas this is from composite components. This is digital green, so we have like 0.16 on the red and blue channels and 0.6 on the green channel. So this is where we want to be.
Because basically, the better the green and the more consistent it is, the more you're using a scalpel, not a sledgehammer. And the sledgehammer takes out stuff we don't want by accident.
There's so many. This is, I green screening. We're doing normal green screening. The things that work well with what we're doing will work well with every other keyer out there. What I think is very valuable is both for the real-time compositing, then you can get a really nice result here. And also, this tells you, even if you're going to go in post, when something is amiss.
Right, so if there's a big highlight hotspot because there was a light simulating light coming on him from the window that was screwing up our green screen and giving us a lot of dynamic range in the green, you'd see that, and maybe someone on set would say, hey, I can fix that for you.
And the amazing thing is when everybody can see the image on set, a lot of the fixes happen automatically. You look up and normally if it's just the effects guy looking away from going, wait, I think this is a little bit too hot, they're like, oh, you'll fix it in post. When it's the comp and they see something terrible going up in the upper land corner, they'll say to the lighting guy, hey, Louis, move over that light, and then we can get a good result.
Yeah, because my assumption on set is that everyone is there to do a good job and to be collaborative. It's just that if they don't know what's going on, how can they sort of fix it for you? Where they can see it, it makes a really big difference.
That was one of the big surprises from all this, is we thought when we went on as we were building a data logging system that would let them save money in post-tracking, et cetera. And what surprised me was the collaboration that it enabled. As soon as you see the live comp go up and you see the whole show coming together, all the different pieces like acting and sound, this, that, the other, on-set, post, all coming together on that screen, then you can make creative decisions because everybody sees it.
That wardrobe item isn't working very well. Let's just swap it out. We can see that now and not having to roto it in post.
So we're in a visual field, so it's actually useful to see what you're doing.
Yeah.
But I'll go through the different stages of this, and I'll pick a low color. Then I can search for a lower green. That sounds good. So then we can kind of see what kind of map that we're looking at. Okay, so we have a reasonable map. Now the neat thing that Ben did is that it's a combination of keyers. So it's a multi-stage keyer. There's a color difference keyer, and and also as well a matless extraction. And that was one of the things that really caught my attention. So this is the matless extraction and stage of that, and this is really good for capturing hair detail, like lenses, like reflections on glass, these sorts of things. And we can tune in how much of that blend that we were capturing based upon that to determine how much of that we want. So we can get down to like fine hair, these sorts of things. Then we can actually bring these all together, and we can get actually a reasonably nice mat with, you can see like hair and the different flyaway bits of the hair on there. And that's more where we want to be. You can see the glass is keying correctly, and we can knock this out in a very, very short period of time.
So there must be a suppression on there as well.
Yeah.
Seeing no green spill.
So we have green spill suppression, so we can remove the excessive amounts of that.
And then presumably tint, otherwise your suppression is just going to go to grey, right, as we take out the chroma from it.
So we have a combination of things, and there's multiple colors. There's the edge control colors, so we can actually adjust the variations of that, to tune it in away or from where we want to be. That's more of the edge tinting. Then we also have overall foreground and background color correction. So for example, if I want to adjust our background coloration, I can shift our gammas and I can shift our levels into a direction where we want. So I can increase our contrast subtly. I'll do it abruptly here so you see it. That way we can dial in quickly the kind of look that we're looking for.
Okay, now if I was doing the novella, this would be the output and we'd use it. But if I'm doing this into post, do any of these values get passed down that, this is what the director saw on set?
Yeah, so for what we do is for every take that we capture, so when you record a take, you hit roll, hit cut over in the takes category. If we roll and we cut, then that saves both the combination of the actual tracking data in a collada file, and it also saves a state file that's the complete system setup, including all the keyer parameters, all the color parameters, where the scene was, where the camera was, all these different pieces. So then you can actually tell in post exactly what was going on in those on-set decisions.
It's very important that you have this pipeline adoption of getting as much metadata into the hands of the actual post artists as possible. Because in Episodic, I think it's been very successful in being able to build a pipeline that uses metadata. I think in feature films, there's a lesson to be learned there because a lot of that stuff gets stripped out in the transcoding. But you are really passing down a lot of this stuff for the case of the Once Upon a Time type Episodic, so those guys can actually use that when putting the shots together.
That they've done a remarkable job. Zoic has built a whole production pipeline for that based around the high-speed data collection we can do with the prevision system. Then they pull that into their post-production pipeline and use it to heavily automate their processing of that area of it. And that's been exciting. The thing that was interesting with metadata is people said, oh, people don't use metadata. And what we found is, yes, they do, if you expend the effort to get them all the way across the river. If you build a bridge partway across the river and then say swim the last 20 feet, then nobody does it.
Right, and so what you're referring to there is that phenomenon of we've got some metadata, but I can't rely on it, or I've got most of the metadata, but not enough. Because if you don't have a complete and absolutely rock stable set of metadata, you're going to go, well, it says that it's a 17, it doesn't look like a 17 to me, I think it might be a 24, I can't rely on this, so I'm not going to rely on it. But these guys can rely on it.
This is, I'll show you kind of what the metadata tracking looks like. So this is the onset, this is what's being captured and recorded inside the system. So there's a couple of things. We have a combination of the time code here. We're reading time code directly out of the HD signal stream. We can also take it from the onset LTC, like analog time code, if people are using that. And in real time, since we have animation coming in, it's detecting the time code on the timeline of the animation, so we know where that is. In real time, we have the position of that, X, Y, and Z.
You might just move the camera on the dolly track so we can see. Okay, so there we go, yep.
So you can see that moving. This is all in centimeters, so it's quite sensitive. We have the pan, so as he's panning back and forth, you see the small angular changes, tilt, roll, all the different components of that real-time shot to be able to see that. And as he zooms in and out, you're seeing the focal length change, and you're seeing the entry people shift around. So it's moving in and out. This is centimeters, so it's moving quite a bit. The distortion will go from, when we're all the way wide, it may be 0 or slightly negative, and then as we zoom in, then it'll change and shift to slightly positive. So effectively, it's going from a barrel distortion at a very wide range to straight when you're slightly zoomed in, to it starts to pincushion toward the high zoom areas. We track the focal distance or the focus distance. So when we rack focus in and out in post, you can tell exactly where we were at.
So now this is a good keyer and a good setup, but what we really also need to do is make sure we actually match the lighting, because it's all very well having a good key, but if somebody's lit from the left in live action and lit theoretically from the right in the background plate, it's going to look wrong no matter how good the key is. Is there any sort of techniques or pipelines to help get the lighting right on set?
The best tool that we've seen is what you're seeing. So you see the background, and the great thing is when you can adjust the live action lighting very quickly while you're looking at the composite to make sure they line up together, and that ends up being the most potent tool to get things to match up. So the background is largely baked textures, so you get the lighting from how we shot it on that particular day. And then for the live action lighting, once they see that composite going up, then you can match it in very, very quickly. All
right, well, let's swap the background out and change our setup and see just how we go. Okay, so now we're set up in a car set and we're driving down, I believe, Santa Monica. So there's a few things going on here that are interesting, but before we even get started, I just want to pick up on a point that we were talking about before we started rolling, which is designing this shot and setting it up. If we were doing this on a green screen stage, you'd be like, well, does that look good? I guess, maybe. Right. Yeah, and because we could see it, there was 50 1-second adjustments we did to get it more to be the way we wanted it.
That, in a nutshell, is what I think makes for a great stage composite. Is all those tiny little, it's not one thing. It's, as you said, 50 little things, getting this right, getting color right, getting our motion right. All these tiny things that when they add up will then make it into a really good composite. And this way you actually see what you're doing fast enough to make those interactions.
And they can be as simple as the camera height, right? Or as complex as how close we sit together or where the steering wheel is, because the steering wheel, as you might notice, is not actually attached to the car. And so I can just see that, right? I can see what looks kind of natural on here versus just doing this because I've got no idea what I'm going to be seeing in post as an actor.
And I think what you're seeing is actually something really fundamental happening in visual effects. I mean, it's the in-camera stuff in the 80s was all done in camera. I mean, it's analog, it's live, so you can see what you were doing. The switch to digital at that point meant a switch to batch processing. Like you hit render and you wait overnight and you see what happens the next day, and that gives you flexibility, but you lose interactivity. And one of the things that I find is very intriguing about this is the ability for multiple people to now work together to make an image look better with that instant interaction on the set.
So now one of the things I'm going to ask if we can play with is focus, because one of my biggest problems with a car shot like this is that people are guessing how defocused the background is relative to the foreground, and they nearly always get it wrong, and so it looks just wrong. But you've actually got the optical characteristics of this lens. So if this lens was on a car mount, what would happen to the background, which presumably you shot as a plate, mm-hmm. I guess.
Yeah, so we shot, this is interesting. There's a couple of areas going on here. One, we have a background plate that was shot with a camera, rearward facing on the vehicle. Then you can also see reflections going up over the hood and the windshield.
Yep.
That was shot at the same time with a camera mounted on the front bumper, pointing up with a hemispherical lens. And that way we have essentially a realistic synchronized reflection map that is synchronized with the background map. And that way you see the trees that are going up over the windshield turn into the trees that you see in the background.
So if we play with focus, then we would be focusing properly, I guess, as we pulled in on you. Yep. So that's going to get a much more realistic view of what it would look like,
exactly,
as opposed to kind of me just guessing in post how much to defocus the background behind the driver.
With the optical characteristics, the optical calibration of the lens, we know at any given point how far the lens is focused away, what the f-stop is, what the sensor size is, and then we're solving the actual defocus based upon those parameters. It's a little harder to see because
this is a 3D car, but can we just swing around to actually show people what this is looking like in terms of, you've got a 3D model, but we've actually got the image plane that is, of course, the image plane that you shot from the real tracking vehicle going down the real road. Okay, so here I am effectively sitting in that tracking vehicle.
So here we're rendering the 3D vehicle, and you can see the reflections going over there. There's a background video plate being decoded and playing. And then you see us, we're the keyed 2D element that is sitting.
Yeah, we are 2D, of course.
And so if we come around to the side of that, then you'll actually see that we are, in fact, just a 2D element sitting inside the 3D driver's seats.
I've never looked thinner.
But the ability to kind of very quickly see how all these things come together is what lets us, what really brings it to it.
So what we've seen, and I know this from other interviews we've done, is that on set, the adoption of this is quite rapid. And in fact, there's often a push from even the writing staff to increase the number of virtual studio days because it enables them greater flexibility.
We've seen that repeatedly with the different shows that we're working on. They'll frequently start out with maybe one day of green screen for an episode. And then, the writing team realizes, wait a second, we can just go. And then fasten your seatbelts. And they'll spool up to 3, 4, 5 days of green screen for an episode, and really take the storytelling into areas that you would have never guessed.
So I'm gonna spring this on our crew without having warned them. Can we actually go handheld like this?
Sure.
So this is, the reason I'm doing this is because this is sort of what might happen on a set, right? It's
yes.
That somebody comes up with, well, we don't want to do that. We want to go handheld. And it's like, well, it wasn't designed for that. So let's see how hard that is to do. I didn't even warn the guys we were doing this. Your cable, I think, is just on the tripod. There you go. Okay, and so now if you wanted it to be a much more, like obviously some story point that this would be relevant on, there you go. Yeah.
And for an actual production shot, we'd be using probably a body buck of a vehicle and putting the reflections on it. It's hard to fit the Mini Cooper into the.
Has there been much of a response from actors? Because I mean, obviously it is quite different, but then by the same token, there is this feedback opportunity. You can actually see what it is that I'm meant to be imagining as an actor.
Yeah, it's worked out quite well, and what we find is that. Frequently the director will have a wireless tablet that has the composited feed on that. They'll walk out and walk the actors through a different area of that. And so we've worked on some shows where at first the director wasn't, they looked at us and said, wow, if you're going to slow us down, we don't want you on the set. Okay, great. So we start doing our thing. And what was interesting is you could see the whole show on the monitor. And so the second day, kind of looking over our shoulder, you can see, what the show is going to look like instead of a giant wall of green. By the third day, he had a wireless tablet, was using it to align all the actors on set, to walk them through every piece of it. And what we find is when it's fluid and fast and responsive, people adopt it very, very, very quickly.
Well, certainly you guys have been recognized by the Emmy that you won at the end of last year, which is totally well-deserved. But
Thank
also
you.
just the adoption rate here in Hollywood. There's a lot of interest in this. And I personally think what we're seeing now, I said this earlier, this is just the beginning. I see this moving very much into feature films. I'm sure you're getting interest in people thinking about that process and as it moves sort of into a more feature film pipeline, as of course the GPUs provide more bang for your buck.
It's where it's going. In terms of both from a creative standpoint and from an economic standpoint, the more that you can do in the moment, then you both win creatively and you win financially.
Well, as funny as it is for us to be driving down Santa Monica doing this, I think I'm going to have to stop, but thanks so much for your time. We really appreciate it.
All right.
Well, thanks so much to Lightcraft for that. It was great. And John and I really enjoyed it. Now, as I said at the outset, that was actually an idea that was posted in the forums because I had asked in the forums what you guys might be interested in. Not all of the classes in background are this way, but many of them this term are this kind of by request format, and I'm really enjoying it. It's great you guys challenging us for stuff, and it causes us to try and work out ways that we can solve those problems and bring you those classes. And of course, we always say that you should spend time in the forums and ask questions because we really do appreciate the input, but particularly this term, I'm having a ball. And we've already filmed other classes that'll be rolling out later this term and even some at the beginning of next term based on requests you've made in the forum. So, I'm Mike Seymour. Thanks so much for being with us. Until next time, see you.